Morning all. We are going to begin our online classes for antenna and wave propagation. So, as all of you suggested, I am starting with module 6. Okay, there's going to feedback I obtained from you. I got an idea it would be better to start with module 6 since we already finished or even conducted online test up to module 4 and 5. So, I think it's better to start with like module 6, and that was your topic module. Okay, so we'll start with module 6. So, what is basically module 6 uh, discusses? But module 6 is nothing but it deals with radio wave propagation. Okay, so I'll share the notes I have made through periods. So based on that note, we can progress your discussion. So, what is a radio wave basically? A radio wave we are using for communication. Okay, so it ranges from a few megahertz to a few hertz to few megahertz. So it is a large spectrum of waves basically that we are using ground wave propagation, sky wave propagation, and space wave propagation. There are mainly three modes of propagation. Okay, so all these modes of propagations we are doing with the help of radio waves. So radio waves can propagate in all these three formats. Okay, so as I said, what is a radio wave? The radio wave ranges from frequency 30 hertz to 300 gigahertz. As I already told, it ranges from some few hertz to some few gigahertz. That means, exactly speaking, 30 hertz to 300 gigahertz. And if you are considering corresponding wavelengths, particularly corresponding wavelength for 30 hertz wave, lambda is c by nu. So it will be around 10,000 kilometers. Okay, so 10,000 kilometers to, and what will be the wavelength corresponding to 300 gigahertz? It will be 1 mm. Okay, so from 10,000 kilometers to 1 mm. The wavelength ranges from 10,000 kilometers to 1 mm. Okay, so in the Earth environment, the propagation of these waves are determined by the characteristics of the wave and characteristics of the atmosphere. Okay, since we are transmitting these waves either as ground wave or as sky wave or as space wave. So here the characteristics of the wave, of course, it will apply. Okay, then in addition to that, the characteristics of the medium or characteristics of the atmosphere is also going to affect the propagation of these waves. So we are going to discuss the three basic modes of transmission or modes of propagation of these waves. That is ground or surface wave propagation, sky wave or atmospheric propagation, and space wave propagation. We will see one by one in detail. Okay. Before that, since our main medium is atmosphere in all these cases, we have to study the structure of our atmosphere. Okay. So we will see what are the layers of the atmosphere at all. Okay. So I'll just show them. Okay. You can see the representation of the layers of atmosphere. So Earth is shown here, and above Earth, the immediate layer, atmospheric layer above Earth is called troposphere, and it ranges up to 20 kilometers from the surface of Earth. Okay, the next one is stratosphere, and the next one is mesosphere, and then comes the atmosphere and exosphere. Okay, it's both atmosphere and exosphere. They are collectively called as thermosphere. Okay, so we will see one by one. And as you are aware, our main area of interest is this atmosphere. So we will come to that. Okay, first we will study about troposphere. Troposphere, as you already saw on this diagram, it is the immediate atmospheric layer above the Earth. Okay. So we can say that troposphere ranges up to a height of 20 kilometers from surface of Earth or mean sea level. That is only our reference weight, mean sea level. Okay. So we can say that actually up to troposphere only our human activities are limited. Okay. When we can say that our Mount Everest is how much height Mount Everest is having, the highest point on Earth, 8,800 meters or 8.8 kilometers. So it is well within the range of troposphere. And moreover, if we are considering the mass of the total atmosphere covering the Earth, we can say that 75 percentage of the total mass, 75 percentage of the total mass is concentrated within this region, or that is concentrated within the troposphere, or within this 20 kilometer distance. Okay, so yeah, that is only the products and units that we are seeing in the atmosphere. And there is one more feature is from this troposphere. As the height increases, temperature decreases. Okay, how it is decreasing? That is also from here. The temperature drops about 6.5 degrees for every kilometer above the surface. So, like if we are moving up, if we are traveling up for 1 kilometer, the temperature drops about 6.5 degrees. Okay, so that much reduction is there for every kilometer rise in this troposphere. Then the tropopause, next region. That is tropopause. The name suggests tropopause. Troposphere is posing. Okay, that means it is the end of troposphere, located at the top of the troposphere. Temperature remains fairly constant here, and it is the basically it is the layer separates the troposphere from stratosphere. We are just jet stream, that is a strong wind occurring in the troposphere, top of the tropospheric layer. That is occurring in tropopause. Okay, this much on this is required. Just you learn on outline. Okay. Next one is stratosphere. It ranges from 20 to 50 kilometers. Okay. Stratosphere ranges from 20 kilometers to 50 kilometers. So this is in the lower part of the stratosphere, like that is from 20 to 40 kilometers, is considered as the lower part of the stratosphere. Here the temperature is almost constant. Okay, and here the ozone layer. You have heard about the ozone layer, and you will be aware of the importance of ozone layer also. Okay, so ozone layer is located in this region. Okay, the ozone act as shield for Earth's surface. That I think all you know. That just you have to refresh it. Okay, next it is the mesosphere. It is from 50 kilometers to 80 kilometers. Okay, so the temperature drops in this layer about minus 85 degrees Celsius. Okay, in this the region, there is no gradual drop of temperature, but it is dropping up to minus 85 degrees Celsius. This is the coldest region of the atmosphere. Okay, this layer protects the earth from meteors. They burn up in this area. Like you might have seen meteors. Okay, so the meteors normally will come up to this region only. They will burn up in this mesosphere. It won't come much deeper into the atmosphere. If it will come much deeper, much deeper, means finally it will collide. Okay, that will be the end of everything. So mesosphere is that way. It is protecting us from the meteors. Okay. The next is thermosphere. Okay. I already told that from the diagram. Thermosphere is containing ionosphere and exosphere. Atmosphere consists of two separate layers, exosphere and ionosphere. The ionosphere is our main area of concentration. Okay. Ionosphere is the lower part of thermosphere. Okay. It extends from 80 km to 550 km. Gas particles absorb ultraviolet and X-ray radiation from the sun. So, in this region, That means the region from 80 to 550 kilometers or the atmospheric region, the gas particles or the atomic particles, gas only is present in the atmosphere, so the atomic particles present in this region, they absorb ultraviolet and X-ray radiations from the sun. Okay, so they become electrically charged. That means they become ions. So they will emit or they will lose one or two electrons and they will become ions. Okay. So that's why this region is called as ionosphere, sphere of ions. In this region, the atoms will be ionized. Okay. So radio waves are bounced off by the ions and reflected back to the earth. That's how the radio communication is. In this region, the reflection of radio waves is happening. Okay. So that we will study everything in detail. Next layer is exosphere. Okay. Naturally, this is the upper part of the atmosphere. It extends from 550 to thousands of kilometers. Finally, it will dissolve into the space. Okay, and we can say that air is very thin here. That is common sense only. It is the topmost layer. Then air density will be much, and gravitational force also will be much. Okay, and this is the area where satellites orbit. Okay. Above 550 kilometers only, we are placing our satellites. So, in this region, satellites orbits the Earth, and the air density is very less. Okay. So, that's all about the general structure of our atmosphere. These are just basic things we need to just refresh. There is nothing much to study in that. Okay, for an engineering student. So, we will move on to the modes of radio propagation. So, already told there are three modes. Okay, ground wave or surface wave propagation, sky wave or atmospheric propagation, and space wave propagation. So why we are using these three modes of propagation? Basically, we want to communicate in different frequencies. That's why we are using these three different modes of communication. Each mode is limited by the frequency we are using. Frequency which we are using for ground wave propagation, it may not be suitable for sky wave propagation. And the frequency we are using for sky wave propagation, that may not be suitable for space wave propagation. So, frequency which we are taking for the communication, that only depends, or that only decides the mode of propagation. Okay. So, we will just see uh, like one by one. Okay. So, first we will take ground or surface wave propagation. Okay. So if the frequency we are using is up to 2 megahertz range, then we can go for surface wave propagation or ground wave propagation. Okay. So up to 2 megahertz means the frequency is low. So at lower frequencies only it is having significance. Ground wave is a wave that is guided along the surface of Earth that you can see from this graphical representation. The tower is there and it is transmitting the signal. The signal is guiding through the surface of Earth. So Earth is round, so it will go through the curvature of Earth and it will reach the receiver. A home is shown as the receiver. So the atmosphere it is shown here. So you can say that it will pass through the which layer it will pass? Mainly it will pass through the troposphere only. The layer which is immediately above the surface of Earth. Since the waves are going above the surface or it is going along the surface of the Earth. Okay. So it permits the propagation around the curvature of Earth. And this mode of propagation exists when the transmitting and receiving antennas are close to the surface of Earth and is supported by its lower edge by the presence of earth. So that is just basic thing only. We already told that these waves they will glide through the surface of earth or it will glide through the curvature of earth. So for that the transmitter and receiver should be like somewhat closer and both should be on ground. Not only the lower edge should be supported by the presence of earth. That means both the transmitting and receiving antenna should be on the ground. Then only it can catch or it can transmit a wave which is passing through the curvature of it, or just which is passing through just above it. Okay, so this that's and it's usually produced by vertical antennas and is vertically polarized. So, what is the polarization of the wave? It is what is the polarization of the wave? It is just the orientation of electric field vectors, okay, in an electromagnetic wave. So here, vertically polarized waves are used. That means in the wave, the electric field vectors will vibrate vertically with respect to the ground. Okay. So next, the limitation. We are moving on to the limitation of this thing. That is nothing but losses. Okay. While passing over the surface of Earth, the surface wave loses some of its energy by absorption. Okay. As you all know, there it is having an uneven surface. Okay, so while going through, while transmitting through the surface, the earth will absorb, definitely the earth will absorb energy from the transmitting field. Okay, so that is that's how losses happening, mainly losses happening in this ground or surface of transmission. Okay, the earth attenuation increases as the frequency increases. So it is suitable at lower frequencies. Okay, it is also called a medium wave propagation and it is used in local broadcasting. So that's all about the basic points about the ground wave propagation. So the main things are just like we are using lower frequencies, 52 megahertz only we will use. And can you say one more limitation for this? As I already told, it is lower frequencies we are using. So like from our previous discussions, from our first and second modules, can anybody say about what will be one more disadvantage of this? Based on antenna height. Yes, like a tall antenna will be quite antenna height will be more since we are using lower frequency waves. Okay, that is also one limitation of this mode of propagation. Okay, so I think yeah, we have completed ground wave propagation, and we just want to study the expressions of just field strength at a distance. That is direct result of Maxwell's equation. That is there is nothing much to derive. This, as far as our syllabus is concerned, we just need to remember that's all. Okay, field strength at distance is given by E is equal to 120 pi HT HR I over 190, where HT and HR are the heights of transmitting and receiving antennas. Okay, I is the antenna current, E is the distance between the antennas, and delta is the wavelength. Okay, so we already seen that the main disadvantage of this ground wave propagation is the absorption by the earth. So if we want to cover more distance or if we want to get more range, more power should be utilized. Okay, so that is also a main disadvantage of this. It is heavily limited by the power. Okay, so if we want to have a larger range, our power requirements will be high. So I think That's it with the ground wave propagation. And one more thing I can add to that, like like for what are the main applications of this kind of translation? Local translation. What you already see about saw about the local translation. Like anyone of you seen that very high tower antennas? Nowadays it is not that much common since these mobiles and all are there. In olden days, big tower antennas were there. Okay, for what purpose those antennas were used for? What purpose? So that is for this ground wave communication. Okay, you might have seen that, like terrestrial communication. Yeah. Okay. So